Hello students, in this session we are going to revise about the coordination compounds. So what I am going to do in whole session is that first we are going to understand about the terminologies, revision of the terminologies. Then second, IUPAC nomenclature of coordination compound. Third is isomerism in coordination compound, Fourth is valence bond theory, and fifth is crystal field theory. So we are going to discuss all these five. So to start with terminologies, we'll take one question. So question is, write the coordination number in oxidation state of the platinum. So here coordination number is a terminology. Then terminology about oxidation state. So what is the oxidation state over here? So how to find the oxidation state on platinum? I'll put platinum to be X. Okay. This is En. En stands for ethane 1,2 diamine. This is ethane 1,2 diamine. This is didentate ligand. It can connect a ligand through two linking sites, right? So, and this is neutral ligand. It doesn't contribute to any charge. So I'll write this 2 into 0. This is negative ligand. 2 into chlorine is -1. So which is equal to +2. The charge on that coordination sphere is +2. So X plus 0 minus 2 plus 2. X is equal to +2 and +2. X is equal to +4. So oxidation state in this case is oxidation state over here is equal to +2. Right? Now what is the coordination number over here? Coordination number, if you see, there are two didentate ligand. This contributes to a two linking site. One ligand contribute to a two donor atom. Since there are two donor atom, this 2 ligand will contribute to 4 donor atom. 4 and this is 2, right? 4 and this is 2. So what we say, a coordination number will be is equal to 6 over here, right? How it is, I'll show you diagrammatically. One of the isomer will write, possible isomer for this platinum is there. 1, 2, 3, 4, 5 and 6. Okay, let's say ethane 1,2 diamine. It is written this way, En. It is written this way. This is chlorine, right? Now what is this En stands for? En is this way actually. CH2, NH2. And this is what the ligand is. To short, we write it this way. Right? Coordination number is 6. So this oxidation state is also called as a primary valency. Remember this. This is also called as a primary valency. Question could be also asked, write a primary valency and secondary valency of the compound. Secondary valency over here is a coordination number. Primary valency is a oxidation state. So this is secondary valency. Right? So these are the things with respect to this question. So this is a question, what is the meaning of denticity of the ligands? Give two example of didentate ligand. Denticity means one ligand will coordinate a particular metal atom by how many linking sites. That is what a density. In proper words, in a definition form, if you want to write in an exam, you can write it this way. So the number of the coordinating ligand, the number, answer for this definition is the number of coordinating ligands, coordinating or liganding, I will write coordinating or liganding sites present in a ligand. It's called denticity of that ligand, ligand. Give two examples of a didentate ligand. For example, one is oxalate. This is didentate ligand. Like oxalate, you see it is derived from oxalic acid. How does oxalic acid looks? COOH. This is oxalic acid. Right? So oxalate is what? You remove this hydrogens. You remove these hydrogens. What will be remaining there? O minus. So this is one linking site, this is another linking site. So in this ligand, there are two linking sites, and a minus 2 charge will be there on this ligand. This contribute to minus 2 charge. That is not asked, but I'm just saying extra information. So next didentate ligand is ethane 1,2 diamine. Ethane 1,2 diamine. It is also written as EN. Okay, EN short form is ethane 1,2 diamine. So here this ligand looks this way: CH2, CH2, NH2, NH2, and these are the linking sites to a ligand, metal atom. They will be connected because there is a lone pair of electron over here, electron rich sites. So this is the answer for this. What do you understand by the term ambidentate ligand? Give one example. So ambidentate ligands are the ligands which has more than one linking site, but it will link to a metal atom by only one site at a time. Okay, by definition, like first I'll explain. Like cyanide. Okay, when it is linked through a carbon, this is called as cyanide. When it is linked through a nitrogen, it is called as isocyanide. Right? So this is the example of the ambidentate ligand. Let's say this is a metal atom, this is a metal atom. So it is linking unidentately one atom, either carbon or nitrogen is getting linked, but one at a time, although there are two linking sites. Right? This is called as ambidentate ligand. The definition, how to write this M stands for a metal, central metal. Okay, central metal. Definition. Okay, ligands which can ligand through, answer for the definition is ligand which can ligate through two different atom, but one at a time. One at a time. Okay, ligand which can ligate through two different atoms in a ligand, but one at a time. It's called as bidentate ligand or ambidentate ligand. It's called as ambidentate ligand. That's it. Like cyanide is there. More examples like NO2 is there. NO2 is an example which can link through nitrogen. It can also link through oxygen. So when it is linking to a metal through nitrogen, this is called as nitrato N, and when it is linking through oxygen, it is called as nitrato O. That's it. Question asked is, what is the difference between a complex and a double salt? So I'll write the definition first. Answer to this, you will understand what is the meaning of double salt and complex. What does it mean? Double salt is a combination of positive. Don't write this in your paper like this. Plus NVE positive, right? Completely. Okay, for subjective exam you have to write this. Consists of positive and negative ions which completely dissociates. Okay, which can completely dissociate into its ions. when dissolved in water. When dissolved in water. Like for example, examples are right. MgCl2. MgCl2. You put this into water, you will get Mg2 plus aqueous and 2Cl minus aqueous. This is solid. You put this into water. You take NaCl solid, you put this into water, you get Na plus aqueous plus Cl minus aqueous. This is what a meaning of the common salt. Sorry, not common salt. Double salt, I mean. Okay. Now, what is the definition of the complex ion? Complex is a salt. Right over here. Complex is a salt. Complex is a salt in which molecular structure of complex ions, retains itself in aqueous solution. Do not completely dissociate into its ions completely. Do not. That is right. That is, do not completely dissociate into its ions. Like for example, if you take an example of this cobalt NH3,4Cl2, this is a coordination pair. Counter ion is this. If you put this into water, what you are going to get is CO NH3,4Cl2 plus this has a one ion aqueous and Cl minus aqueous. These are the things which you are going to get. And this is what the difference between a double salt and a complex. Next is what is meant by chelate effect. Now chelate effect, what is the meaning of chelates? When the chelates are formed. The thing is that chelates are formed when there is a bidentate or tridentate or a tetradentate or a hexadentate, or we can say a polydentate ligands coordinate to form a 5-membered or a 6-membered ring. Like for example, who can form a chelate? Oxalate ion can form a chelate. Okay, this is called as oxalate, right? C2O2, C2O4, 2 minus. This can form chelate. Then who else can form chelate is En, that is ethane 1,2 diamine can form chelate, right? So the thing is that for example, I have a metal cobalt, let's say En, and twice I'll write Cl2. Okay, Cl2 over here. Cl2, and I will write outside sulfate. So in this case, cobalt will be connected this way. Let's say this is En, a didentate ligand, right? And this is Cl and Cl. You see the coordination number also. Although 1, 2, 3, 4 ligands are there, coordination number is 6 over here. Means one ligand is contributing 2 coordination numbers. Now this is ring-like structure. It's called as a chelate. So by definition, if you want to write a systematic definition in exam, is when a didentate, answer is when a didentate or a polydentate ligand coordinate, okay, ligand containing containing donor atom position in such a way that they form 5 or 6-membered ring structure. Okay, 5-membered or so whether they coordinate with a central atom. When a didentate or a polydentate ligand containing donor atom position in such a way that they coordinate. Okay, we'll write they coordinate with central metal atom to form 5-membered or 6-membered ring. 5-membered or a 6-membered ring. The effect is called chelate effect. So this is a definition you can write for your exam. Always remember that any compound given, if any compound is forming a chelate or having a denticity, bidentate, tridentate ligand, then that compound will be always more stable. This gives more stability to the complex. Thank you.